RAG connects enterprise knowledge to language models, but every connection becomes part of the security boundary. In this module, we'll look at how to protect ingestion, embeddings, vector storage, retrieval, and model context, so answers stay authorized, trustworthy, and safe. You've already secured the core AI stack: architecture, identity, privileged access, APIs, application design, and guardrails. Now we extend those same controls into the knowledge layer, where RAG depends on embeddings, vector stores, retrieval, and context delivery. In a RAG system, data changes form as it moves from source documents into chunks, embeddings, indexes, retrieved context, and finally a generated answer. Each transition is a trust boundary. Provenance, content safety, permissions, and policy checks all need to be verified before context reaches the model. The key mindset is simple. Retrieved text is not automatically trusted. Treat it like external input until integrity and authorization are confirmed. This expands the attack surface because documents are no longer passive storage. They become live inputs to the model. Risk can enter during ingestion, embedding creation, retrieval, or prompt assembly. Malicious text can steer behavior. Poisoned vectors can distort relevance. Weak permissions can leak documents. And retrieved snippets can expose secrets. Security has to cover the full pipeline. Indirect prompt injection moves the attack from the user prompt into trusted-looking content. A PDF, ticket, wiki page, or email may appear normal, but include instructions aimed at the model, such as ignoring safeguards, revealing secrets, or sending sensitive data. When retrieval pulls that text into context, the model may treat it as guidance. Defenses need to surround the RAG pipeline. Filter content before retrieval, then validate retrieved context and outputs afterward. Embedding poisoning targets the matching step in RAG. Instead of changing the model, the attacker makes malicious content look unusually relevant. Keyword stuffing, semantic mimicry, or adversarial phrasing can push that content into top retrieval results and crowd out better sources. The risk is that the answer may sound grounded while relying on misleading context. Defenses should combine provenance checks, trust scores, diverse retrieval, and monitoring for documents that appear relevant too often. RAG security breaks when retrieval trusts the vector database more than the source system. A user may lose access in SharePoint, Confluence, or a tenant workspace, while embedded chunks still carry old permission metadata. If retrieval does not filter by current user, role, tenant, and document status before sending context to the model, the answer can leak secrets, financial records, legal files, or customer data. Authorization has to happen at retrieval time, not just in the application interface. A vector database is not just a search component. It can expose sensitive relationships, customer context, and internal knowledge through embeddings and metadata. Treat it like a high-value data store. Build isolation between tenants, workspaces, and domains from the start. Encrypt data in motion and at rest. Restrict network paths, enforce role-based access, and use metadata filters to prevent cross-boundary retrieval. Log ingestion, queries, updates, deletes, and admin actions, so investigations have evidence. Tenant isolation has to be enforced before retrieval, not after generation. Start with trusted identity claims, then convert them into server-side policy filters for tenant, group, region, classification, and document ACL. Those filters travel with every vector query, so similarity search only runs inside the authorized scope. Where boundaries are strong, partition collections. And never let the client weaken these constraints, because semantic relevance is not an access control decision. Vector database security also requires layered platform hardening. Encrypt every connection with TLS and protect stored vectors, indexes, and metadata at rest. Keep database traffic private through VPC peering, private endpoints, service mesh rules, or tight IP allow lists. Use role-based access so admins, ingestion jobs, retrievers, and analysts get only the permissions they need. Then audit aggressively for bulk exports, broad cross-tenant searches, failed authorization checks, and sudden query spikes. Ingestion is the first security boundary for a RAG system. Before content becomes chunks and embeddings, it should be classified, scanned, checked for provenance, inspected for PII or secrets, and bound to access metadata. Sensitive or external sources should require approval, not automatic indexing. Every chunk and embedding needs lineage back to the source document. If validation fails, quarantine it rather than letting questionable content quietly enter retrieval. At this checkpoint, the goal is to make security metadata travel with the knowledge. Classify each document so access rules and retention policies follow it downstream. Scan for malware, macros, links, and active payloads before parsing. Verify provenance through trusted connectors, signatures, or repository metadata. Then detect PII, secrets, credentials, and regulated records. Each check should produce metadata, and failures should trigger blocking, redaction, quarantine, or human review. Authorization in RAG only works if permissions survive every transformation. When a document is split, each chunk and embedding must carry its own access metadata: owner, groups, tenant, classification, region, source URI, and expiry. Those tags also need continuous sync, so revoked access is reflected in retrieval. For sensitive repositories or broad indexes, add approval gates, either automated policy checks or human review, before content becomes searchable. Retrieval is not just similarity search. It is a security decision made for every request. Start with the user's identity and claims, then enforce policies and tenant isolation before ranking results. After retrieval, inspect the context for sensitive data, prompt injection, policy violations, and source trust. Each item should be allowed, redacted, or denied before prompt assembly. Finally, log the filters, decisions, and exact context sent to the model for auditability. The key lesson is that RAG security is lifecycle security. Protect ingestion, embeddings, vector storage, retrieval, and model context together. Combine identity, application security, guardrails, hardened vector databases, and authorization at retrieval time. Next, we widen the lens to cloud posture and AI supply chain risk.